So let's jump into Unit 2 IPC. This is the guided practice for your remediation packet. We're looking at some academic vocabulary that you'll need to know for the retest and to understand forces. So, defining the terms, first is force. Force is any push or pull on an object. We experience force all the time. When you're sitting in a chair, you're experiencing force. When you're running, you're experiencing force. Forces just surround us. Equilibrium. When we talk about forces being in equilibrium, that means all forces acting upon an object are equal in all directions. Net force. Net force is the sum of all the forces acting on an object. So when the net force is zero, you're at equilibrium. When the net force is not zero, you are not at equilibrium. A Newton, the unit is used to describe, or it's the unit of force. We say the unit of a Newton is an amount of force. An applied force, that is that push or pull on an object. Gravitational force is the amount of force due to gravity. We've experienced that on Earth. It keeps us on the ground. Normal force, that is the force that opposes gravity. It opposes it to the perpendicular to the surface that it's standing on. So if you're sitting in a chair, the normal force is going straight up. From the bottom of the chair up. And then we have frictional force. Frictional force is caused by friction. It's caused by not being able to slide on something easily. Magnitude. Magnitude is a scalar quantity. It only has the number. It doesn't have direction. Inertia. Inertia is the ability of an object to just want to stay in motion. Mass is the amount of matter. Weight is a product of your mass times the gravitational force. Those are some academic vocabulary that you need to know. Looking at your next section is free body diagrams. And it says use the following free body diagram to answer the next three questions. And it says what is the gravitational force? You can always find the gravitational force. It's listed as F of G. And it's the force that's going down. Gravity pulls us down. And so it has a force of 30 newtons. The applied force, you can look at the applied force, it's going to be F of A. And we can see this, that it is 20 newtons. And the normal force, always opposing gravity perpendicular to the surface. And we see that it's F of N, which would be our normal force, which is 30. We see that F in that little tiny thing there is F of F, which is our frictional force. They didn't ask for that, but there's a little extra information. Looking at net force, it says what is the net force acting on the next three free body diagrams. So when we're looking at net force, it's the sum of all the forces. So we see that these guys going up and down, they're equal, so it's not moving up or down. But we see we have a frictional force of 10. We have an applied force of 20, so the net force would be 20 minus 10. So we have a net force of 10 newtons on that free body diagram. When we're looking at this, they're opposing. Normally we would write them as that arrow going this way and that small arrow going that way. That's how we could write it, saying that our gravity and applied forces are the same. And essentially they just put the tips of the arrows together. And so, but this is just still 20 newtons. This is 50 newtons. So the net force is 50 minus 20. So therefore it's going to be 30 newtons. And lastly, we see that we have 30 and 30, and then so those guys are equal, they balance out, and we have 10 and 50. So 50 minus 10 would be a net force of 40 newtons. Looking at the difference between mass and versus weight, and it says what would change for a person walking on the moon, mass or weight. Your mass is a set amount of matter, and it doesn't change where you are in the universe. Weight does, though. Weight is dependent on gravity, because so weight is force of gravity. Okay, that is our mass times the acceleration due to gravity. So we just put G for gravity. So when gravity changes, your mass stays the same. Well, your force due to gravity, your weight is going to change. So if we're on the moon, it has less gravity than the Earth, and so therefore your weight would be less. Your mass would still be the same though. B, it says speculate on how a person from Earth weight would change if they were suddenly on a planet with a gravity much greater than Earth. So if this gravity goes up, your weight would then go up because your mass stays the same. And then lastly, it says describe the difference between weight and mass. The main difference, weight can change, mass will stay the same. Looking at force equals mass times acceleration, solving equations for this. When we're looking at this, it's just F equals ma. M is mass, A is acceleration. So on the first one, it's just our mass times our acceleration. So 10 times 4.3 is going to give us 43, and our unit for force is newtons. So in the next one, we have F equals ma. We're solving for m. So we solve for m, and we'll have mass equals force all over our acceleration. So in this case, we'll have 10 divided by 9.8, and we get 1.02, and this would be kilograms. And then lastly, we have a force we're solving for acceleration, and that's just going to be our force all over our mass equals acceleration. So our force of 98.9 newtons divided by 22 kilograms is going to give us an acceleration of 4.495 meters per second squared.